if we do a leap in history, I'm sure some of you have seen this kind of interesting picture in Ohio of Bruce Greenshield measuring what turned out to be the first ever measurement of a traffic jam. And it was at some kind of festival in the middle of Ohio in 1935. If you fast forward 20 years, that's when the first PD of traffic was explicitly written by Lighthill, Whittam, and Richards. There's two papers in the mid-50s, kind of using hyperbolic conservation laws to describe traffic, so macro models. And then if you forward another almost half century, Fuyuyama did that experiment in Japan, in which he asked drivers to drive in a circle and essentially maintain distances. And this video became really famous because this was also one of the first recorded spectacular instantiations of string instability or stop and go or phantom jams. There's lots of different ways to characterize what's happening here. Essentially, humans not able to maintain distances and leading to terrible traffic instabilities. Now, over 10 years after that, one of our former students, Dan Work, with Benedetto Piccoli, Benny Siebold, and John Sprinkle, reproduced that same experiment, but inserted a self-driving vehicle in that loop, which you see here with the arrow in black, except now it's just driven by a human, so you see these instabilities. And then when it turned out, it just did it now, the autopilot, so the automation manages to smooth the flow, and you see the oscillations immediately damped out. You can see it both in the movie, in the numbers, and in the red curve, which I'm hovering over here. And it's quite spectacular because essentially 1 out of 22 vehicles is enough to smooth the flow. And if you read the energy consumptions from the OBD port, you get 42% reduction in energy, which is phenomenal. So you can see a lot of progress made in almost a century between the first measurement of traffic jams and this ability to control traffic. Now, one thing I'm going to show you now is the same thing in simulation that was done 1 year later. And this one was done by Kathy Wu, who is now a professor at MIT. She's an alum at Berkeley. And what she did is she managed to essentially reproduce the same thing in simulation in Sumo, but this time the red car is automated. The blue car is the only thing the red car can see. And when the red car crosses that line that you see here, it will turn on the autopilot. And it just did. And as you can see, that now reproduced the same thing you just saw in the movie. And so if you're listening carefully now, you're probably wondering, why am I showing you a simulation that was achieved in 2018 when an experiment was achieved in 2017? It seems you're walking backwards. There's a good reason for it. And the reason is that if you think about what was done in 2017, it was mostly done by derivation of an explicit controller, the follower stopper, that relied on a lot of different articles that are model-based. In fact, we counted the number of articles written between the first 1935 Bruce Greenshield publication and 2008, and there's about 10,000 articles or more published on traffic modeling. And then once people started to really focus on string stability, there's probably at least 1,000 articles on string stability and related problems and stabilization. And that essentially all led to this experiment, which was spectacular. And the point that I'm making with that simulation that happened 1 year later is that that simulation and that stabilization did not require a model. And that's kind of, it's kind of a pivot, I guess, in approach, because the way Kathy did that is essentially by training an RL policy on the outcome of a microsimulation, but the policy does not have a model of its own car, nor of the other cars. It just has access to a reward provided by the software. So you can view this as model-free deep RL. And that's pivotal because the performance is the same. So you could kind of look at this and say, wow, there's like 80 years of people looking at models, and I'm one of them. I published myself a lot of models. And then suddenly you can kind of redo the same with no models. And so that was the start of us scratching our heads and figure out, well, could we leverage that to do other things that maybe could not do with model, or could we also just use models as a starter point for doing this? And this is kind of the rest of the talk today.